Now, the goal seek tool has been quite handy when we had a target profit in mind, which was, in this case, to break even. That means no profit and no loss. You might also try setting the target profit to 2000 by clicking here on the what if analysis goal seek and set this to 2000 and define a variable cell. Now in this case, we want to see variation in the sales volume. You select this and click OK. You have the result over here. That's 175 units of sales, considering all other things remaining the same. Now what if I want to try something more? That means not only change in sales volume, but also change in selling price per unit. Now this is where the limitation of goal seek comes in. It can only work with one variable at a time. So if you're working on change in sales volume, you cannot define any potential change in selling price simultaneously. And this is where the solver bails us out. Solver can help you do complex statistical calculations, but you can also use it for some simple calculations as well as for quick analysis. Now we can find the solver tool under the data menu or the tab, and towards the extreme right of the ribbon you will see the analyze section, under which we have the solver icon. Well, in case if you cannot find this icon here, do not worry. Let me help you get this over here. For this, we need to enable this add-in. It's an add-in which is already there in Excel, but it needs to be enabled. By default, it is dormant. It's not enabled. So in order to enable any add-ins in Excel, we go to File menu. Under this, we need to look for options. Now, if you do not see options in this list, we can click on More at the bottom, and then we can find options. This leads to a new window, that's Excel options. Now, what we are looking for is add-ins. On the left-hand side, we have add-ins, and on the right side, we will see a whole bunch of add-ins here. Now, solver is something which has already been added to my tools, so I have it over here. But if you do not see it here, not a problem, because it's yet to be enabled. So at the bottom over here, you have this manage. There's a drop down. By default, you will see Excel add-ins. If you see something else, just select Excel add-ins from this list and click go. So we have 4 set of add-ins available over here. All we need to check is the solver add-in. This should be checked. As of now, we are not concerned about the other add-ins. We only need the solver add-in. Once this is checked, click OK, and you will have a new section over here called Analyze and the solver icon over here. Now, let us use this amazing tool to determine multiple variables to reach the target number. So first I click on solver. Now it asks to set objective. Now here, when we say objective, it's what is your goal? What is the target that you're looking at? I want the profits to be at 2000. So the cell or the target cell is this. While in case if you're not able to change it here, just clear off this space and then click on the cell. Now further, it also gives you some more options where you want to set it to max possible value or lowest possible value, or you want to set a predefined value. Now I want to set it to 2000. Now when I'm talking about maximum possible value or minimum possible value, well, maximum could be anything, but that may or may not make sense in this particular case. But what makes sense over here is this, the value of 2000. So next, what solver asks is by changing which variable cells. I click on this, I select this, then I hit comma, I select this, comma, and then the variable cost. So we have 3 variables over here and changes in any of these. And I would like to get the target result, that's the profits, to 2000. While the sales volume, selling price, and variable costs are adjusted. For now, without making any further changes, let us just click on Solve. So Solver tried out something and it has come up with some results here, and we can see that the profits are at 2000, but at what cost? We see that the sales volume is at 78.29379 and these many units sold at 62.35171 per unit, while at the same time the variable cost set at 17.648. Now, in case if you're okay with this answer, you want to retain these results, you can click on OK. But in case if you want something different, you can click on Cancel and it rolls back to what it was earlier. We can see that there was a drastic reduction in variable cost, selling price as well, and the sales volume somehow marginally increased. Now, this is not what I need. I do not want to see sales volumes in decimals. It's a whole number. Either I sell a complete unit or I do not sell it. There is no half unit that I would be selling. Now, when I say selling price, there is a limit to a selling price. Maybe I do not want to sell it beyond 60, or rather I would say maybe I cannot sell it beyond 60 due to competitive pressure. And when it comes to variable cost, I do not want the variable cost to be below, let's say 25, because come what may, the maximum discount that I could get. So the lowest possible value that I can set over here is 25. That's the lowest possible cost at which I can get all the raw materials or any other inputs for my production. So now I want to define these parameters, and that is again where we go back to Solver and we add some constraints. So I click on Add. Here we have, so first thing, sale volume. I want to define sale volume to be an integer. It's an integer. Okay, that's a whole number and not decimals. Once I'm done with this, I have some more parameters to be defined or constraints to be defined. So I'll click on Add and move on to the next one. If I click OK, that's it. The window will be closed and we would be back to Solver like this. But I want to add some more. So I click on Add. Now this time I want to define selling price per unit to be any of these. Let's say the selling price, I have an upper cap limit of $60. So selling price per unit should be less than or equal to 60. Add. Further, I also want the selling price per unit to be greater than or equal to, let's say, 40. Anything below 40 would put me in losses. So I want it to be set to 40. And click Add. Now next, the variable cost. I click on cell reference and variable cost is selected. It should not be anywhere less than 25. Now, if I have defined all my parameters or the constraints, I can click on OK. And here we have all the 4 constraints specified, wherein the C2, that's the sales volume, must be an integer. And then C3, that's the selling price per unit, should be less than or equal to 60, but greater than 40, greater or equal to 40. That means the selling price should be somewhere between 40 and 60. Further, we have variable cost, which should be greater than or equal to 25. Now, there is no need for us to define the upper limit for variable cost, because the higher the variable cost, the far away would we be from our target. So by default, it will try to reduce the variable cost to meet our target. Now, in case if you want to make any amendments or changes here, you have this change button. Click on the one that you want to change, and then you have the change option here. Now let me go back. And in case if I need to delete any, I can just click on the constraint and click delete. Now moving on, it also asks us to select a solving method. Now by default, it's GRG nonlinear. If you click here, you will find some more options. But this is something we don't need to touch, because all these would form part of any advanced statistical calculations. So we'll leave this to GRG nonlinear and click on solve. So it says that solver found a solution, and take a look here. We have the sales volume changed to 100, selling price changed to 60, and variable cost set to 25. So the variable cost cannot go below 25 and selling price cannot go beyond 60. Now, if you want to achieve a target profit of 2000, then definitely you need to sell more. And by how much? I need to sell 100 units. And with this selling price and this as the variable cost. And that is when I get the desired profits. Now, if I like the answer and if I want to retain it, I can click on OK, or I can also click on Save Scenario and give a name here. Let's say Scenario 1. Click OK. Now I can click on Cancel and we come back to our numbers earlier. Now, where did that scenario go? What if analysis? Do we have this? Yes. Now we have the scenario over here under what if analysis and scenario manager. We created one scenario here, right? So anytime you want to test it out, you can click on show and it comes back. Okay. And now if you click on close, you see all the numbers have changed. Now I undo this and we are back to our previous numbers. Okay, so let's redo this and set this here. Now let us explore another interesting tool under what if analysis. That's data table. Now please do not confuse this with the Excel table that you can format as a table here under the home menu. Well, this is totally different because although the Excel table does hold data in it, it's not the data table because the core purpose of this Excel table is to manage a set of related data and format it such that it's easily identifiable. But in case of data table, that's under the data menu and what if analysis, this is purely an analytical tool. What Excel says, data table, it sees the results of multiple inputs at the same time. So it essentially means that it allows you to try different input values for, let's say, these variable cells and see how the changes in these cells affects the final result. That's the profit in this case. Now, the only condition here is that the result must be directly or indirectly linked or connected to the input cells where we want to test any variance. Now, before we start preparing our data table, let us first understand the purpose of data table. Let's say I want to know how much will be the profit if the selling price was 60. So we can just enter the number 60 here and we can see the profit at 750. Now, consider this. You are in a meeting with a potential investor or maybe a business partner, and they would like to know the level of profits if the selling price were, let's say, at 40, and what if the selling price was at 45. 50 is something what we have already calculated, 55, 60, and 65. And these are the selling prices that we want to test on the profits. So we know that when the selling price is 50, the profits are 0. That's no profit, no loss. And if the selling price per unit is at 60, the profits are at 750. But what about the rest? I'll have to go back, manually change this to 40. I see the profit as negative 750. Just type it here and note it. Further, let's test it out on 45. It's negative 375. Hit enter. We know at 50 it's a perfect 0. That's no profit, no loss. But what if it's at 55? It's positive 375. That's a profit of 375. 60, we have already tested it out. And now 65. It's 1125. Now that's quite inconvenient here. Now let's say in the middle of a meeting, another person comes up and says, let's try it out at 70. So we want to add another 70 here and then go back, make the change here to 70 and then hit enter and make note of this here, 1500. Now this could get really inconvenient and also affect the flow of your discussions, especially if you're occupied with entering the prices and noting the profits back and forth. So someone comes up and says, let's revisit the price when it was at 45. You go back and forth, making the changes. It would have been convenient if you would have already prepared such table before the meeting, but it does take some time and you can never expect to note down all the possible criteria. Let me repeat that sentence right from convenient, okay? Now, it would have been convenient if you already had prepared such table before the meeting, but it would really be difficult to assume or guess what all potential selling prices would be considered during the meeting. So at the most, you might have a sample list over here. But then just imagine if you were asked to try out some similar analysis with changes in variable cost. Something like, let's say, variable cost when it was 25, 30, 35, 40, 45, and 50, and so on. Now, it would really help me if there is a tool that can help me test multiple pricing and cost scenarios all at once in just few clicks. Well, data tables are here for our rescue. With the help of data tables, you can avoid manually noting down each of these results for each variance in input values. Now, let me show you a few data tables here. Now, these two over here are the single dimensional data tables. That means they just have one variable input for each of these criteria. Now, if you carefully observe, these numbers over here are exactly the same as what we see here. These numbers are exactly the same, and this is something that we have achieved with the help of data table. We can also achieve similar results in this format as well, that's change in variable cost. Further, there's also something called as a two-dimensional data table, wherein it focuses on multiple two inputs at the same time. Now let us try to build this from scratch. Okay, so first we'll test the impact of change in prices on the profits. So here, first things is the first step that we need is to link a particular cell to the final output cell. That's the profits. I'll make this look bold with this cell over here. Now let us have the input values or the test criteria. So that's selling price while at 40 and then 45. Well, I could just copy paste it from the left as well. I'll take it from here and paste it here. So here we have the target cell linked. That's the final result linked over here. Whereas the rest of them are all manually entered. None of them are linked. Okay, we need to ensure that although we see that the selling price per unit is already given, we are not linking here. We will manually enter these values and ensure that the arrangement is such that these parameters are not in the same column where you have the cell linked to the final result. Now, while you have this arrangement in place, select these cells, come to data menu. Under data menu, you have what if analysis and then select data table. Now it asks for row input cell and column input cell. The easiest way to decide whether you need to give row input cell or column input cell is, well, the parameters that you want to test, are they arranged in a single column or are they arranged in a single row? Well, they are arranged in a single column, so let's call it as column input cell. And where do I want to test these values in? I want to test these values against the selling price per unit. So column input cell will be the selling price per unit cell reference. Click OK, and that's it. You have the data ready all at a click. something that we were manually copying all this while, it would have taken me closer to around a minute or 1.5 minutes, if not at least half a minute. Here, I just got it done in just few clicks. How did this happen? So what exactly is happening here? We have this number and against which we see what the profits will be like. So if the selling price was to be at 55, the profit is expected to be at 375. Although we don't see any changes happening here, these are nowhere dependent on these, but we still see, based on different scenarios, the potential results for the profits. So for example, let's say we have 55. If the selling price I were to change to 55, this data table says that the profit would be 375. So let's hit enter. And yes, it is. Well, what if the selling price was 70? As per the data table, it must be, will it be 1,500? Let's check. Well, yes. So data table, with just a matter of few clicks, helped me save a lot of manual efforts here. Instead of manually typing this and copy pasting it over here, Excel did this automatically. Well, Excel didn't do anything different. This is something which is not visible to us, but Excel is also taking this value, applying it here, which we had mentioned as a target column reference cell. It takes the value as if it's copying this, paste it here, get the result, copy and paste the result here. Again, next take 45, put it here, copy the result that you will get and paste it here. Take 50, put it here, copy whatever profits that you get while this is at 50 and paste it here. And it goes on so many times. There are multiple level of iterations happening, but that is something that is not visible to us. It's happening in the background. All we can see is we have just clicked on OK on that data table window and everything was readily done for us quite conveniently.